Today, we will learn about finding the derivatives using a first principle. To understand this conceptually, let's start with understanding of a gradient. For an example, that if I do have a straight line, then gradient of that straight line is in fact the slope of this line. How we calculate the slope of a straight line, it is very simple that, for example, we know the values of the coordinates of 2 points. Let's say this is a point A and its coordinates are x1, y1, and this is the point B and its coordinates are x2, y2. Then the gradient is the ratio of increase in the y divided by the increase in the x. So the gradient m of this line is the change in y divided by the change in x. So this means it is actually y2 coordinate minus y1 coordinate divided by x2 minus x1. So this is a very simple to find the gradient of a straight line. Now, if for an example that if we do have a curve and the curve is of any function f of x, then what would happen? And in this way, for example, the curve is following that it is going like, for example, kind of a curve over here. And now our task is that to find the gradient at this point A. Now, if we consider that we do have another point B, as we actually use the method for a straight line, then you can see that the straight line between the point A and B is not exactly following the curve. So then the gradient of this line AB, which is the straight line, a yellow colored line here, will have a different gradient than the gradient at the point A. Now you can understand this very easily that if, for example, I bring this point B towards A, then what would happen that, for example, at this point, now the difference between this green curve and a yellow line is quite much smaller compared to the previous difference. Now you can very easily understand that if, for example, that this point B, we bring it very, very close to A, then the gradient between these 2 points A and B will be almost the gradient of this curve at the point A. So what does this mean? We can try to use this methodology to find the gradient. Let's say that this point A, it has the coordinates. It will have the following coordinates that, for example, here we have the coordinate x and the y coordinate is f of x. So then the coordinates of point A are x and f of x. Now at the point B, our coordinates are following that if we consider that this increment in the x is just, for example, h. So then our this x coordinate will be x plus h, and then coordinates of our point B will be following that x plus h and f of x plus h. Now, this actually the y coordinate value is f of x plus h. Now, you can actually see very easily that our gradient of this actually the line AB will be following. That is the change in y, meaning that the function f of x plus h minus f of x. So y2 minus y1 divided by x minus, sorry, x plus h minus x. So now this is actually simplified in the following way. We will have the function f of x plus h minus f of x divided by h only. So this is, of course, our gradient, delta y over delta x of any function f of x. So with our these lines, we understood that this gradient will be more accurate at a point A if our this difference between x plus h, that is h, is very, very small. So then what we do, we apply the limits that this h is approaches to 0. Now, this gradient, you can write it as a dy over dx, and here this differential part of x is approaches to 0. So what is this? This is actually the definition of differentiation, or you can say it is actually the first principle of finding the gradient, finding the derivative of any function f of x. So using this definition, we can find the derivative of any given function. Now, let's try few examples using this definition to find the derivatives. Okay, let's consider that we have a function f of x. Now, what we need to find, this is f of x, which is equal to x square. What we need to find? We need to find the first order derivative of this function using first principle. So what is the definition? Definition is the following, that dy over dx is equal to limit h approaches to 0. F of x plus h minus f of x divided by h. Now, what is f of x? It is x square. So what will be f of x plus h? That will be simply x plus h and its square. Now let's put these values back in the definition. So we will get dy over dx is equal to limit h approaches to 0, x plus h square minus x square divided by h. Now we can open this square, so it will become that the limit h approaches to 0. This is x square plus 2x h plus h square minus x square divided by h. Now, this x square and minus x, they have been cancelled with each other. Then we will have the following simplified form, dy over dx, which is first order derivative, that the limit h approaches to 0. Now, what we do have, we left with the two terms 2x times h plus h square. So between these two terms, h is a common factor. So we can write it h times 2x plus h divided by h. So now this h will cancel with that one. Then we left with the limit h approaches to 0, 2x plus h. So this is the factor that we left with. Now, what we can do, we can apply the limit on it. Then this 2x term, it has no any h, so it will survive. What the others will be 0. So we left with only 2x. So what does this mean? This means that the derivative of the function f of x is equal to x square is equal to that. You can also write f derivative of f of x derivative, meaning f bar or f prime, this equal to 2x. And similarly, you will find that if your function f of x is x cube, its first order derivative with the definition, you can find that it will be 3 times x square. So you can actually also utilize this first principle to prove it, and then we actually can develop a general formula for f of x is equal to x power n. Then the first order derivative of this function must be n times n minus 1. So what is happening that the power of our variable is actually becoming the coefficient of the variable, and the variable is losing its power by 1. As you see, we have x cube, 3 becomes the coefficient, and the power now has reduced from 3 to 2. As here in the general formula, if the power of x is n, n becomes the coefficient, and x will lose its power by 1, and it becomes n minus 1. So this is actually a general formula for finding the derivative of any function f of x is equal to x power n. And then this method is actually the first principle of finding the derivative of any function. Now, if you remind yourself that where we started our this understanding of taking the derivatives, we started with the definition of gradient. So it means that, in fact, the first order derivative is the gradient of the function at any point x. For an example, that if you see this, our very first function, which is x square, it is a quadratic function. The derivative of quadratic function is here is linear because it is 2x. The derivative of x square is 2x. So derivative of quadratic function is linear. And then if you can see that the derivative of a cubic function is x square, so meaning it is quadratic. So one order has reduced because in derivative, the power reduces by 1. So this is a very simple and a straightforward understanding of taking derivative using a first principle. And our basic concept that we understood that the first order derivatives of a function actually is the gradient of the function. Now we can apply the same method with some other examples to solve the derivatives. Now you can try this exercise to solve these all questions, and these all questions you need to solve using first principle or a definition of differentiation. Okay, now we will learn how to take derivatives of polynomial functions. Before learning this, let's revise our so far learning. We learned that if, for example, we have a function f of x, and that is x power n, then its first order derivative will be that this power becomes coefficient and the power of the variable will reduce by 1. And if, for an example, if we have a function where we already have a coefficient like a is a constant number and times x power n, then for the derivative, that this constant, it will remain as it is. So n times a, that will be our new coefficient. Then we will have x power n minus 1. And another thing that we learn that actually this derivative is the gradient, which tells us the change in your function relative to its variable. For example, here, this function f of x, the derivative tells us the change of this function with respect to x. So then if, for example, we have a constant function or a constant term of a function that f of x is 5, so now you can see that it is in fact independent to x. So then its derivative will be 0 because there is no change with respect to x. And this f of x is equal to 5. You can understand that this is actually y is equal to 5. So this is a straight line graph. Here we have x-axis and we have y-axis. So then f of x is equal to 5. So that will be a straight line, and the gradient here is a 0. So derivative is a 0. So now if, for example, we have a function, which is a polynomial function, and this function have multiple terms. For an example, that if I have a function which is y is equal to 3 times x power 5 plus 2 into x power 2 plus 7x power 1 over 2. So now how we can take the first order derivative of this function, so dy over dx. So now you can see that on the right hand side of this function, we have three terms, term 1, 2, and these 3. So this derivative will be applied on each and every term individually. For example, the first term is 3 times x power 5. So this power 5 will multiply with the 3, as you can see in this formula. So 5 times 3 is 15, and the power of x will reduce by 1. So it will be 4 now. And in the second term, which is 2 times x power 2, we will have 2 times 2, 4, and the power of x will reduce by 1. So now it is only x power 1. And the next term here, the power of x is half. So half will multiply with the 7. So we will have a half of 7, 3.5, and x power will reduce by 1. That means 1, half 1 over 2 minus 1. So our final answer is 15 times x power 4 plus 4x plus 3.5 5, and x power half minus 1 is minus half, so negative 1 over 2. So this is our derivative. So now we can also consider that if, for example, there was an other term and that term is, let's say, 9, it is a constant term. So then the derivative of constant term will be 0. So answer will be the same again. So this is a simple method of taking derivatives of polynomials, or you can say the functions that have multiple terms. What method is that we differentiate each and every term individually. So that is a very simple method to solve these kind of questions. So let's try one more example to understand our this method. Okay, if we have a function like y is equal to x power 3 times 3x plus 1. So in this function, you can see that it is written in the form of two factors. So first we expand this function, we simplify it. So then now we write it in the form of individual terms. Then 3x cube, it will multiply with the 3x. So answer is 3 times x power 4. And x3 times 1, answer is x power 3. Now we have two individual terms. Now we can apply our this derivative to this function. So dy over dx, that will be equal to that we are going to apply this derivative to individual terms. Then this x power is 4. 4 is going to multiply with 3. Answer is 12, and the power of x will reduce by 1. And here the coefficient already is 1. So 3 times 1 is 3, and x power will reduce by 1. So it is 2 now. So this is the answer. That if, for an example, we have a function like y is equal to x minus 2 divided by x square. So now this time you can see that it is actually written in the form of two factors. Again, what other is dividing, so we can actually write it as x divided by x square minus 2 divided by x square. So now what we did, we actually have written this common denominator as individual. So now we have two individual terms. So you can further simplify it that x over x square. So this power is 2 and it goes to numerator. So it will turn into x power negative 1. So then this will be minus 2 x power negative 2. Now, here we can very easily understand that what would happen, that here the derivative dy over dx of this function, that will be negative 1 as a coefficient, and x power negative 1, meaning that we need to reduce it by 1. So answer is negative 2. Then the next one here, this will turn into positive 4 because we have a negative 2 and we times it with the negative 2 because this power will become the coefficient. So it will multiply with this coefficient negative 2. So answer is positive 4. And here x power, you need to reduce power by 1. So from negative 2 to negative 3. So this is the answer. So you can also write it as 1 over x square plus 4 over x power 3. So in this way, you can actually take the derivative of the function that have multiple terms. If the function does not have multiple terms, then you can first simplify to have individual terms. Then you can actually find the answer. Okay, so for we understood that how we need to take the derivative of a function that has multiple terms. Okay, let's solve another question, which is a little different. So first, read the question. For a function f of x is equal to 12 minus 4x plus 2x square, find the equations of the tangent and the normal at the point where x is equal to -1 on the curve with equation y is equal to f of x. So let's understand this question. The question is that if we look at the function, that this function is a quadratic function, meaning that it will be a parabola. So let's say this is our parabola. And what we need to do, we need to find the equation of tangent and normal at x is equal to -1. So let's say that our negative x is equal to -1 is over here. Then the tangent is the straight line which is actually touching this parabola only at a one single point where x is equal to -1. The normal line is which is perpendicular to the tangent line, or you can say it is actually the perpendicular at x is equal to -1. So we need to find the equations of these two lines, tangent t and normal n. Now, what we need to do, we know that these both tangent and normal are the straight lines. So the equation of the straight line is y minus y1 is equal to m, which is gradient of the line, times x minus x1. What is x1 and y1? That are the coordinates of the point where you have this tangent and the normal. So we know that x1 that is equal to -1. And this is actually for our parabola. Y is equal to, I can also write it as 2x square negative 4x plus 12. So we can find the y coordinate by putting x1 is equal to -1. So then our y1 coordinate will be that -1 square is 1. So 1 times 2 is 2. So -4 times -1, answer is +4, and plus 12 is there. 12 plus 4, 16, 16 plus 2, 18. So our y1 is equal to 18. So now it means we know the both coordinates of this point, -1 and 18. So these are two coordinates of our point where we have tangent and normal. Now we actually need to find the value of gradient. We know that if we have this parabola and its equation is given and we take its first order derivative, the first order derivative will be the gradient of this parabola as a function of x. So it means that we are going to take the derivative of parabola, and the answer is the following, that dy over dx, and this is the gradient of the parabola, that will be equal to that. This is actually given in multiple terms, so we can actually find the derivative of each term. Derivative of 2x square is 4x, and then -4x, its derivative is -4, because derivative of x is 1, and constant term it is 0. Now, this is actually the gradient of parabola as a function of x. Now, if we put here that x is equal to -1, that will be the gradient at this point where x is equal to -1. So then here the tangent is touching this parabola only and only at this point. So it means that the gradient of the tangent, because it's a straight line, it's a constant gradient. So gradient of the tangent will also be equal to 4 times -1, -4. So then we will get -4. -4 is equal to -8. And that is the gradient of the tangent. Now we know that actually the normal line is orthogonal line to the tangent, meaning it is at 90 degree, it's perpendicular. So we know that the gradient of the perpendicular line is the reciprocal to the perpendicular line. So the gradient of the line is a negative reciprocal, so -1 over -8. So then the gradient of the normal line is 1 over 8. Now you can find very easily the equation of the tangent and equation of the normal. So equation of the tangent will be y minus 18, which is the value y1, is equal to the gradient of tangent is -8 times x. Then the x1 is -1, so it will be +1 over here. So now you can simplify. So y is equal to this -x times 8 is -8x times -1, then +18. So now our equation of the tangent y is equal to -8x plus 10. And this is y tangent, meaning the equation of the tangent. So we can actually move this -x to the left-hand side. +8x, -10 is equal to 0. So this is the equation of the tangent. Then here you can also find the equation of the normal by actually using the same general equation. So we can do it as following. So for the equation of the normal, so y normal is -18, because normal is also at the same point, is equal to the gradient of the normal is 1 over 8 times x minus -1, that will be +1. So now you can simplify it. This 8 will multiply to the left hand side. So 8yn for the normal. So, and then this will be -144 is equal to x plus 1. So we can simplify it. So this time we have x is positive on this side. It will be 8yn -x -145 is equal to 0. So this is the equation of the normal. So here, what we actually understood, that if the equation is given, the first order derivative is the gradient, and then that will also be the gradient of the tangent at any point x on this function. So then we can use the general equation of the straight line, because tangent is a straight line, to find the equation of the tangent, and then the negative reciprocal of the gradient of the tangent is the gradient of the normal. So then we can also find the equation of the normal at the same point. Hope you understood it.